Hello everyone. Let us now discuss today's LeetCode POTD problem. We are given with the pre-order traversal and the post-order traversal. So what does this pre-order and post-order traversal mean? Here we are given with the root node. Then by going to the left and then to the right. So we are going from root to the left and to the right. So this would be our pre-ordered traversal. Now, what is this post-order traversal? In the post-order traversal, we go to the left first and then to the right and then we go to the root. So if you see clearly, I go from 1 and then to 2 in pre-order traversal, then 4 and then to 5. Then I go to 3 and then here for this node I go to 6 and then come here and go to 7. Now, how does this post order traversal work? Here we are given with these things like 4, 5, 2, 6, 7, 3, 1. So the first thing, as I said, go to the left and then go to the right and then go to the root, right? And then go to the root. So I'm going to the left first and then going to the right the second time and going to the root node. So this is how the post order works. So if I do the same thing to the right subtree, it would be 6 is the left node and it is 7 the right node and the root node is 3, and after visiting this left node and after visiting this right or left subtree and the right subtree, I am going to the root node. Now the problem here is how I can construct this tree. So in pre-order traversal, as I said, I start from the root and after root I go to the left, right, and then I go to the right, sorry, to the left and then to the right in pre-order traversal. Now what I'll do in post-order traversal, I go to the left and then to the right and then to the root node. So if I say I'm going from 1 to 2 in pre-order traversal, what does that mean? That means the root node 1 is having a left node of 2. This is as simple as that. Now I'm having this 4 here in the post-order traversal and I am having this 5. What does this 5 mean? So here I go to the next element to get the left node. Now here the post order traversal, the 5 is having, as I say, the root node. If I consider the 5 as my root node, the previous one would be my right node. So why shouldn't I take the 1? Why shouldn't I take this one? Now 3 is my root node. If I say this as my root node, the right would be, that means the right node to 1 is 3. So by going to the left every time, I'll get the node which is right to the root node. So if I say 1 as my root node, the one previous to me, the 3 is my right node. Here if you see, I got the same thing. 1 to the right, it would be 3, and 1 to the left, it would be 2. So by using this logic of this formula, which is most important, right? For pre-order traversal, we'll use root, then left, and then right. Now, in post order traversal left, then right, and then root. Now, the problem here exists when we need the right here and the left here, but there is no problem at all as I am creating this right with the root node in the post order traversal itself, and I am creating this left in my pre-order traversal itself. So, to know clearly, let me take the big example. Here I have the pre-order traversal. This one a pre-order traversal, this one post-order traversal. I'll do exactly the same thing which I did earlier. So I do not see or look at this tree and construct tree from the beginning, from scratch, right? So what I said to you, if this is the node, the next will be my left node. So I create one and I said the node which is next to me in pre-order traversal would be my left node. Then what would be the right node? For that I go to the one, and the right node to 1 is 3. So I think this is clear for you. Now I go to the next element, which is 2. Now the node which is left to 2 is 4. Now let me go to the 2 which is present here. The node which is right to me is also 4. What does this mean? So imagine I have created, here comes the logic, here I have created 2. What does this mean? That means I have a node here, some value, but this 2 is already present here. That means this 4 is having a right node. That means here the node is already traversed. So 2 is having a 4. That means this 4 is already connected with my node 2. So when I got the left node, that means the node which is to the right of my pre-order traversal and the node which is left to my post-order traversal, if these are already present in my tree, then I do not make a node because these are already created. Now let me go to the next one, which is 4. So the next element, the left node to my 4 is 7. Now I search for 4 and the 7 is already present. That means the 7 is saying that this 4 is already connected to my node. So then I'll go to my next node, which is 7. The node which is left to 7 is 3. And let me go and create this 3. But if you see, this 3 is already present. So there is no need to create this again. That means here I have left with no nodes. Here also I have no nodes. Here no, no, and here no. So immediately it goes to this node which is at here. That's why. So I don't have any nodes here and any nodes. So it immediately goes here. That's why I got a 3 to the left. That means I don't have any nodes to the left or right of 7. So I go to the node which is at the right subtree of my root. So no need to create. Now let me go to the next node, which is 3. The node which is left to 3 is 5. The node which is left to 3 is 5. And the node which is right to 3 is 6. The node which is right to 3 is 6. So I construct a node 6 which is right to 3. Now let me go to the next element which is 5. The node which is left to 5 is 8. The node which is right to 5 is 9. So I construct a node right to 5. Now I go to the next node which is 8. So go to the 8. Here the node which is left to 8 is 9. Okay, I'm creating this left node, but to create that I already have a node which is 9 here, so I stop creating 9. Now I have 8 and the previous one is 2. That means the node which is right to 8 is 2. If you see, the 2 is already present, so there is no need to create a node to the right of 8. Then I go to 9. For 9 I have 6 as the left node. So if I do that, this 6 is already present. That means there are no left or right nodes to 9. Now if I search for 9 here and I got 8 as my right node, then this 8 is already present. So it already means 9 is having no left or right nodes. Now I go to the next element which is 6. Here 6 is having a left node of 10. Immediately I create this node 10. Now the 6 is also having a right node as 10. So I go to 10, and as I am having the same node, that means it is having only one child for this node 6. I think that's it. Here we have created the nodes, and you might ask me here, what if I created right nodes instead of creating left nodes? That's why if there are exist multiple answers, you can return any of them. You can create like anything. Now, what would be my algorithm? Let me start algorithm. What would be my algorithm? I'll start by creating an ordered map which stores int the value and the tree node, so that I get the address where the node, the value or the node which is present, and I create a scene which stores the nodes which are already present, which are already present. Now I iterate post order and store. Before that, where should I store this indices? Post indices indices. I'll store indices of values in post indices. Now I'll go through and iterate all the nodes or elements in pre-order traversal, in pre-order which is given to me, and I'll get the value, and where is the index, the post indices, right? Where is the index of this value? Now if I didn't see this something like pre-order of I plus 1, and I also need to specify, right, I plus 1 is less than n, so I create a left, and also if I didn't see post order of index minus 1 and index minus 1 is greater than or equal to 0, then I create a right. So this is how you solve this problem. At last, you will be returning the tree. And if you want this code, it is in the link of the description. Go and check it. If you like this video, share it to your friends and do subscribe to my channel. Thank you.